A magnetar should not exist. It is a stellar corpse that actively breaks the fundamental laws of chemistry. It is a dead star that wields a magnetic field so incomprehensibly violent it can dissolve the physical bonds of matter. To understand the massive scale of this threat, we have to look deep into the graveyard of the Milky Way. When a massive star, much heavier than our Sun, burns through its nuclear fuel, it dies in a catastrophic supernova explosion. The outer layers are violently blasted into the vacuum, leaving behind only the crushed, collapsing core. This remnant is what we call a neutron star. It is a glowing, hyperdense sphere of degenerate matter measuring roughly 20 kilometers across, yet it contains the mass of our entire Sun. For decades, we looked at the night sky and told ourselves a comforting story about cosmic danger. We assumed that the ultimate predator in the universe was the black hole. We thought that gravity was the supreme, undisputed force of destruction. We built our models and our nightmares around the slow, inescapable pull of a singularity. We told ourselves that as long as we stayed far away from an event horizon, our solar system was safe. We assumed the vacuum of space was a vast, insulating barrier. We felt secure on our blue planet, trusting the billions of miles of empty void to act as a perfect, localized quarantine zone. But here's the catch. A rare fraction of these neutron stars do not die quietly. During the violent collapse of the supernova, the rapidly spinning core can trigger an extreme dynamo effect, amplifying its internal magnetic field to levels that defy human comprehension. The quiet ember becomes a magnetar. To understand the terror of the magnetar, you have to understand the brutal physical reality of the surface. The gravitational pressure crushing this 20-kilometer sphere is so immense that protons and electrons are violently fused together into pure neutrons. A single teaspoon of this stellar material weighs roughly 1 billion tons. If you dropped a standard marshmallow onto the surface of a neutron star, it would hit the crust with the kinetic energy of a modern nuclear bomb. The surface is a perfectly smooth, solid crust of iron, heated to tens of millions of degrees Celsius. It is a spinning city of iron, locked in the dark. But the magnetar takes this extreme gravity and weaponizes it with a magnetic nightmare. The Earth is protected by a gentle magnetic field, measuring roughly half a Gauss. It is just strong enough to guide a compass needle and gently deflect the solar wind. A standard refrigerator magnet pulls with a force of about 100 Gauss. A magnetar generates a magnetic field of roughly 1 quadrillion Gauss. That is a 1 with 15 zeros behind it. Think of the Earth's magnetic field as a gentle, drifting fog. It is barely noticeable, moving slowly around you, keeping you safe from the harsh sunlight. A magnetar's field is a solid, crushing wall of concrete, moving at supersonic speed. It is a force so absolute that it physically alters the shape of space and matter around it. The magnetic field is so violently dense that it forces the vacuum of space itself to become polarized. Light cannot travel in a straight line near the surface. The photons are actively split and bent by the sheer strength of the magnetic lines. We thought magnetic fields were just invisible lines of force. We were completely wrong. At 1 quadrillion Gauss, magnetism becomes a weapon of mass destruction. If you were to somehow approach within 1,000 kilometers of a magnetar, the physics of your own body would immediately betray you. The magnetic field is so intensely powerful that it actively overpowers the strong nuclear force holding your atoms together. The spherical electron clouds surrounding your atomic nuclei would be violently crushed and stretched into thin, useless cylinders. You would not be crushed by gravity, or incinerated by heat. The complex chemistry that makes up your cells, your bones, and your blood would simply undergo fundamental dissolution. We thought this absolute level of destruction was safely locked away in theoretical physics. We assumed magnetars were so incredibly rare and distant that they could never physically reach across the void to touch us. We were completely wrong. Then, the December 2004 strike changed that. On December 27, 2004, a massive, invisible wall of gamma and X-ray radiation violently slammed into the Earth. It was a blinding flash of high-frequency energy that immediately triggered radiation alarms on multiple scientific satellites orbiting our planet. The European Space Agency's cluster mission, a constellation of 4 heavily shielded probes specifically designed to study Earth's magnetic field, was completely overwhelmed by the sudden strike. The highly sensitive particle detectors on board were instantly maxed out and blinded. Astronomers around the globe scrambled to trace the origin of the violent blast. They fully expected to find a massive, localized supernova detonation in our immediate galactic neighborhood. What they found instead was something much smaller, much further away, and infinitely more terrifying. The radiation front came from a dead stellar core located roughly 50,000 light-years away on the absolute far side of the Milky Way galaxy, deep within the constellation Sagittarius. The source was formally catalogued as SGR 1806-20, what astronomers have come to call the silent eraser. The silent eraser is a magnetar. It is a spinning iron city, generating a magnetic field so violently unstable that its solid crust occasionally cracks under the immense physical tension. These sudden, violent fractures trigger what astrophysicists call a starquake. When the ultra-dense crust of a neutron star snaps and realigns by even a single centimeter, the resulting magnetic explosion is apocalyptic. During the December 2004 starquake, the silent eraser released a giant flare of pure gamma radiation. In exactly 0.1 seconds, this tiny 20-kilometer sphere emitted more total energy than our Sun produces in 100,000 years. The blinding blast wave expanded outward at the speed of light. It crossed the vast, chaotic emptiness of the galactic core. It pushed through dense walls of nebula dust. It completely traversed 50,000 light-years of empty space just to reach us. We thought 50,000 light-years was a perfectly safe distance. We told ourselves that half a galaxy of separation was an absolute, impenetrable quarantine zone. The silent eraser proved us wrong. When the radiation front finally reached our solar system, it did not just wash over us harmlessly. It physically crushed the Earth's sun-facing ionosphere. The extreme radiation violently ionized the upper layers of our atmosphere, brutally stripping electrons from atoms and drastically altering the electrical properties of the sky. For a terrifying, unexplainable moment, low-frequency radio communications across the planet were completely disrupted. Satellite navigation systems glitched and actively dropped their signals. A dead star on the opposite side of the galaxy had physically reached out and punched our atmosphere. Let's pause here because I want you to understand the full picture. We are not talking about a slow, predictable cosmic event like a planetary orbit or a slowly dying sun. We are talking about a microscopic, invisible trigger on a dead star that happened 50,000 years before human civilization even existed. The iron crust shifted by a fraction of an inch. That tiny, violent mechanical snap released a localized magnetic shock wave so powerful that the resulting gamma radiation crossed the entire Milky Way and actively damaged our planetary shielding. Think of the cosmic scale required to achieve that. It is the exact equivalent of a sniper firing a bullet from another continent and successfully shattering a glass window in your living room. That raised an obvious question. What happens if the sniper takes a shot from closer range? Imagine you are standing outside on a clear day. The sky is bright blue, the temperature is comfortable, and the world feels perfectly safe. You are completely unaware that 10 light-years away, roughly twice the distance to our nearest neighboring star, a magnetar has just violently fractured its iron crust. You would not hear anything. You would not feel a sudden, rushing wave of heat. The gamma-ray front moves at exactly the speed of light, meaning there is absolutely no physical warning before the strike. When the radiation wall hits the Earth, it does not physically blow up cities or violently crack the tectonic plates. It does something much more insidious. It completely strips the planet of its chemical armor. In 2005, astrophysicist Brian Gantzler and his research team at the Harvard-Smithsonian Center for Astrophysics ran the mathematical models to simulate a magnetar detonation occurring within 10 light-years of our solar system. The resulting data was apocalyptic. The sheer volume of gamma radiation would instantly penetrate our upper atmosphere and annihilate the ozone layer. The high-energy photons would violently tear apart diatomic nitrogen and oxygen molecules. These shattered atoms would immediately recombine to form a thick, global layer of toxic nitrogen dioxide gas. The sky would turn a sickly, bruised brown. We built our entire civilization under the comfortable assumption that the atmosphere is a permanent, impenetrable shield. We blindly trust this invisible layer of gases to keep the extreme hostility of space at bay. But the math proves that a magnetar can simply reach across the dark and switch that shield off. It does not need to physically enter our solar system. It does not need to use gravity to violently pull us in. It just flashes once, and our planetary defense is permanently deleted. That's not the scariest part. The most terrifying aspect of a magnetar is not its raw destructive capability. It is its stealth. Black holes have massive, undeniable gravitational footprints. We can track them by watching how they tear apart neighboring stars and violently devour huge disks of superheated gas. We can map their locations and chart their movements. Magnetars are fundamentally different. Because they are incredibly small, only 20 kilometers wide, and incredibly cold compared to a main sequence star, they are practically invisible in the optical spectrum. Unless they are actively eating material from a binary partner, they emit almost no visible light. They are dead, cold spheres of iron quietly spinning in the dark. We cannot easily see them. We only know they exist when they detonate. Currently, astronomers have confirmed the existence of exactly 30 magnetars lurking inside the Milky Way, 30 silent, hypermagnetic bombs. And those are just the ones that happen to have flared in the brief 50-year window since we launched our first orbital X-ray telescopes. Given the estimated rate of supernovae and neutron star formation, astrophysicists confidently calculate there are likely millions of dead magnetars drifting through our galaxy and thousands that are currently active and capable of a starquake. What I find most difficult to accept is not the scale of the destruction. It is the 30. 30 confirmed. Out of millions. We are not mapping a threat. We are counting the ones that have already announced themselves. We are essentially walking through a massive galactic minefield, completely blindfolded. We have absolutely no idea where the next strike will come from, or how close the sniper might actually be. The most unsettling realization about this galactic geography is our absolute blindness. We look up at the familiar constellations and map the bright, stable stars. We confidently navigate by them. We write poetry about them, but we are completely ignoring the invisible, hypermagnetic corpses hiding in the exact same spaces. The 30 known magnetars are scattered indiscriminately across the galactic disk. Some are thousands of light years away, safely isolated in the deep void. But we cannot mathematically guarantee that one is not silently drifting into our immediate stellar neighborhood right now, winding its magnetic field tighter and tighter. The reality of our cosmic geography is that we are not isolated. We orbit a quiet, stable yellow star, but we are actively drifting through a dense, chaotic galactic disk filled with the invisible corpses of dead giants. The silent eraser was 50,000 light years away. It was on the literal opposite side of the galactic center. If a magnetar detonation occurred just 10,000 light years away, well beyond the absolute extinction zone, the immediate biological impact on the ground would be survivable, but the technological destruction would be absolute. When the gamma radiation from a closer starquake violently slams into the Earth, it does not just ionize the upper atmosphere. The sudden influx of extremely high-energy photons creates a massive electromagnetic pulse that physically couples with the Earth's own magnetic field. This violent interaction induces massive, uncontrollable electrical currents directly into the planetary crust. These rogue currents immediately seek the path of least resistance. They would flood into our global power grids, surging through the long transmission lines that connect our cities. A blinding flash, a melted grid, a silent planet. The most unsettling part is that we have absolutely no early warning system for these events. We cannot predict a starquake. The magnetic field of a magnetar is twisted and tangled deep inside the star, locked directly into the solid, ultra-dense crust. Over decades, the intense rotation of the dead star winds the magnetic field lines tighter and tighter. The mechanical tension builds relentlessly, forcing the iron crust to bend under pressures that defy human comprehension. Eventually, the solid matter simply reaches its absolute breaking point. It snaps. The crust violently cracks, releasing decades of pent-up magnetic stress in a single, catastrophic explosion. Because the resulting wave of destruction travels at exactly the speed of light, there is no physical way to see it coming. The strike and the warning arrive at the exact same instant. You cannot prepare for an attack that outruns the concept of foresight. We have spent centuries looking up at the stars and viewing the vastness of space as a protective, insulating buffer. We thought the billions of miles of empty vacuum between solar systems meant that we were fundamentally safe from the violent mechanics of the larger galaxy. But the terrifying physics of the magnetar completely destroy that comforting illusion. Space is not a quiet, empty ocean separating isolated islands. Space is a highly conductive, chaotic firing range. The magnetic field of a dead star does not respect planetary boundaries. The energy released by a fracturing iron crust does not dilute fast enough to keep us safe. A sphere of crushed matter, the size of a small city, can actively reach across the galaxy and physically touch our atmosphere. We are sitting perfectly exposed in the crosshairs of an invisible, heavily armed fleet. There is a philosophical weight to all of this. We consider ourselves the masters of our own planet. We have come to believe that because we mapped the continents and split the atom, we have secured our permanent survival. We look at a black hole and comfort ourselves with the knowledge that we are safely outside its immense gravitational pull. We focus our fear on the slow, predictable monsters of the cosmos. But the true apex predator of the Milky Way does not need to slowly pull us in. It does not need to consume us to destroy us. A magnetar simply spins in the dark, quietly building extreme tension in an iron shell. It is a frozen, hypermagnetic bomb waiting for a microscopic structural failure. It is a stark, physical reminder that the rules of physics that govern our quiet solar system are a rare, fragile exception to the brutal reality of the universe. The vast majority of the cosmos operates on a scale of violence that our biology is completely unequipped to survive. We are floating through a dark graveyard filled with loaded weapons. The safety catch is permanently broken. We are just hoping the next shot misses. Thanks for watching, and I'll see you in the next one.